quite a very great session this morning. I enjoyed it. I'm Godswill Akhigbe from Health and Safety Executive, and my presentation is Hydrogen Carrier Gas in GCMS, a sustainable alternative to helium for measuring PAH, that's recycled aromatic hydrocarbons in workplace. Sorry. PAH are toxic compounds. They are commonly found in places where you have low or incomplete combustion, and they are carcinogenic, and it's very risky to have them around. And these are common with companies where you have gas flaring, like petroleum companies, you have coal companies and construction companies. And the implication of this is that these compounds can be gotten to the skin through dermal absorption, through inhalation and ingestion, which makes it a critical compound to be considered. And the measurement of these compounds, organic compounds, is very critical. Not just measuring it, but the accurate measurement of it is very critical. That's why we're using GCMS, which is a analytical equipment that helps to measure these compounds. And in the GCMS, one of the key parts is the column, and the column is a place where we have the compounds being separated. Now, not just separating the polycyclic aromatic hydrocarbons, proper separation is very important, and the carrier gas is a major determinant of the proper separation and identification of these compounds. We have carrier gas such as nitrogen, helium, hydrogen, and argon, which nitrogen is very common, but it requires that the run will take a long time. Helium is very useful. It's the most common one that every lab is using, but the problem is it's becoming rare. Several labs are using it. You find children using it in their balloons. And because it's a rare gas, everyone is looking for a sustainable alternative. So we're switching to hydrogen gas, which can be generated in a simple way by the use of water and hydrogen generators. Now that brings us to a good part where we want to eliminate the cylinders from the lab and move to hydrogen generators. A very good system that it uses simple electrolysis to generate the hydrogen gas. So in our lab, we had a method developed for the use of hydrogen carrier gas and helium carrier gas on GCMS. Very simple technique. Same procedure, but the only difference is that for the helium carrier gas, we use a pH-specific column, while for the hydrogen carrier gas, we just use a general column for it. Now, the results using helium show that the run was about 26 minutes, while for hydrogen carrier gas, the run was for about 15 minutes. Hydrogen carrier gas helped to save time in the run, and that was a profound one because we're also able to separate phenatrins and anatrins. If you consider around this, the separation within the phenatrins and anatrins is better here compared to when we find it here. And that's a very good one because if a run is compressed from 26 minutes to 15 minutes, you expect that there should be coelution. Not just that, hydrogen carrier gas helps to give good separation of all the peaks. It makes it easy for identification and measurement. Now, this is the separation when we zoomed in, and you could tell that these two peaks are overlapping compared to these other peaks from the hydrogen carrier gas, which is well separated. So it's easy to tell the measurement, both of them. Now, this is a real life analysis we did in the lab using hydrogen carrier gas. Now, considering this, one of the reasons why this result was quite effective is that hydrogen has very low viscosity. So the mass transfer rate was very high, and then the run time was shorter using hydrogen carrier gas compared to when you use helium carrier gas, and saved about 40% of the run time. Now imagine we have about 50 to 500 samples from different companies. Best thing we would want to trade is our time. Find a way to reduce the time for our analysis instead of running several analyses that will take weeks. And then beyond that, we have very good peak separation, or the peaks were narrower with the hydrogen carrier gas than that for the helium carrier gas. And the beauty of it is that we're able to maintain resolution. The maintenance of the resolution is important, and that's something we also discovered using hydrogen carrier gas. We tried it for pH for several samples and for other environmental pollutants, and we realized that the peaks were consistent. Even when you run that same analysis months after, you will find consistency with the peak resolutions compared to when we use the helium carrier gas. And that's also another study that we're trying to consider. Then the sensitivity increased using hydrogen carrier gas than when we use the helium carrier gas. Yeah, several persons are worried. Is hydrogen not explosive? The safety part of it. It's no longer a problem because the use of the hydrogen generators require that the hydrogen is generated on demand. So the equipment that generates the hydrogen gas on demand. And since hydrogen is a common resource we have in the lab from water, you just place water inside the hydrogen generator. It's easy to generate it compared to when we are using helium carrier gas, when you have to order for the helium, have cylinders in the lab, and then the lab is filled up. You need manpower to carry the helium. Then the cost of helium is also going up because of the demand for it. Helium costs about £1,000 for a cylinder in the United Kingdom. It might be cheaper in other countries. But so if you consider that, everyone would like to go for hydrogen carrier gas in terms of performance, in terms of peak resolution and identification. And then application of the use of hydrogen carrier gas in other environmental analysis has also been found to be effective, though there are some challenges which require that if you're analyzing hydrocarbons, it's best to pay some cautions to it. Halocarbons, it's best to pay some cautions to it and apply a very strict method. Thank you.